October 2025. The calendar feels ordinary, yet the sky above whispers otherwise. For the first time in recorded history, two cosmic wanderers from completely different origins are racing toward the same destination. Our Sunday. One is the interstellar visitor catalogued as 3. I divided by Atlas. Slender, green-tinged, and swift, carrying a chemical signature that bends the rules of everything astronomers thought they knew. The other is Comet Swan R2, bursting into brilliance with a tail stretching across the night sky, as if painted by an invisible artist's hand. Their convergence is not just an astronomical curiosity, it is the kind of event that mathematics suggests should happen once in millions of years. Yet, here they are, arriving almost together, as though they have agreed on an appointment at the very heart of our solar system. Scientists track their paths with mechanical precision. Radio dishes hum across the globe, while observatories in Chile and Hawaii whisper back streams of photons and data packets. Yet, for all our instruments, for all the patient labor of machines, there is a truth no machine can quite hold. The night sky is alive, and it is speaking to us. Out there, these two messengers carry not only ice, dust, and gas, but questions too heavy for silence. Questions about whether coincidence is ever truly coincidence, or whether we are watching a choreography scripted long before humanity learned to look up. Step outside on a crisp October evening, away from the wash of street lamps. Look west after sunset. Swan R2 unfurls across the sky, with the drama of a cosmic curtain. Its tail sweeps upward like a torch, an immense veil shimmering against the fading light. Nearby, 3, I divided by Atlas, lingers as a faint emerald smudge, delicate yet purposeful, its green glow unmistakable for the trained eye. To see both in the same night sky is to feel dwarfed. Yes, but also implicated, as if the universe had staged this moment and cast us, the watchers, as unwilling characters. What does it mean for two strangers to arrive in our system together? The scientific explanation is probability stretched to its unlikely limit. Yet in the silence of space, where no sound travels, we cannot help but imagine intention. History tells us that comets were omens, harbingers of change. Ancient Chinese astronomers wrote of sweeping tails as broom stars, sweeping away dynasties. Medieval chronicles feared them as warnings of famine or war. Today we try to scrub away such superstition with the antiseptic of science. And yet, when we witness the emerald glow of 3I divided by Atlas and the blazing veil of Swan R2 sharing the same sky, the old feelings stir again. Perhaps not fear, but awe. Perhaps not prophecy, but a reminder of our fragility beneath the vast machinery of space. Inside sterile laboratories, scientists count molecules. Spectrographs whisper of cyanogen and diatomic carbon, glowing green under solar light. Numbers appear on screens, brightness curves, orbital refinements, chemical fingerprints. The language of data is precise, but it does not still the unease that creeps in the longer one stares. Because the truth is this: the instruments tell us what is, but never why. Why now? Why two together? Why at a moment when our telescopes will soon be blinded by solar glare, unable to watch the very instant these travelers reveal their secrets? It is almost as if the universe intends to hide the climax from us. The poets would call it fate, the philosophers might call it a test. The scientists, most of them, call it coincidence. But there is a growing whisper, even among the careful, the cautious. What if coincidence is not the simplest explanation? As the objects sink deeper into the sun's light, the question sharpens. What if something does not want us watching? This is where science merges with myth, and myth becomes a kind of philosophy. For millennia, humanity has sought meaning in the heavens. We turned constellations into stories, planets into gods, comets into warnings. Each new discovery has chipped away at those myths, but never fully replaced them. Because data alone does not satisfy the human heart. We crave narrative, we crave intention. And so, As October 2025 unfolds, we look up at Swan R2 and 3, I, divided by Atlas, not only as astronomers, but as storytellers, as dreamers, as children pressing our faces against the dark glass of the cosmos. In one sense, what is happening is ordinary physics. Ice warms, sublimates, sprays gas and dust into space, and sunlight sculpts those materials into tales we can see from Earth. In another sense, it is extraordinary, a cosmic coincidence so unlikely that it strains credulity, and so we begin to imagine, could Swan R2 be a fortress? Could 3, I divided by Atlas be a scout? Are we watching a dialogue written not in words but in light and trajectory? These are the thoughts that keep astronomers awake at night, not only in the halls of NASA or ESA, but also in the quiet solitude of backyard observers. In villages where the sky is still dark, children point binoculars at the heavens and gasp at Swan's veil. In crowded cities, tired workers pause in the streets, craning their necks to glimpse the strange glow, even if only faint. It is in these human gestures so small, so brief, that the meaning of October's convergence becomes clear. For the universe may or may not have intention, but we do. We give it meaning because we cannot do otherwise. This story begins not with certainty, but with mystery. Two lights, two strangers, two paths crossing near our Sunday. And as they converge, we find ourselves at the threshold of both science and imagination, asking questions that echo louder than any data point. What are they? What do they mean? And perhaps most haunting of all, what if this is not random at all? Tonight, we stand at the edge of knowledge, staring into a sky alive with emerald fire and silver veil. October 2025 has come, and with it, the chance, perhaps the only chance in our lifetime, to witness the universe writing in a language we do not yet know how to read. Discovery never begins with thunder. It begins with silence, with the quiet persistence of photons falling on sensors night after night. Imagine the Atlas survey telescopes, standing in the Atacama Desert, their mechanical eyes sweeping across the heavens. On July 1st, 2025, one of those eyes caught a faint flicker, a single pixel out of place. To anyone else it might have been noise, a glitch, a nothing. But when orbital mechanics were run, the truth emerged. This was no ordinary wanderer. Its path was hyperbolic, a signature of something not bound to our Sunday, a messenger from beyond, the third confirmed interstellar visitor in human history. It was christened 3, I divided by Atlas. And then, as if one revelation were not enough, another visitor followed. September 11th, 2025. In imagery from Soho's Swan instrument, an amateur astronomer named Vladimir Bezugli spotted something odd, a rapid brightening, sharper than expected. Within days, it was confirmed. A new comet, C divided by 2025, R2, Swan R2. Unlike Atlas, it was no alien. It was born in our own Oort cloud, that vast halo of icy bodies encircling the solar system. But its sudden blaze was startling, its tail majestic, reaching across the twilight sky like a banner. Two discoveries, two arrivals, months apart yet destined to share October. Was it chance? The mathematics say, yes, improbable, but not impossible. Yet from the beginning, the timing unsettled even the most disciplined astronomers. One interstellar scout, one native giant, arriving at the same stage, as if summoned for the same performance. Data streamed in. Telescopes across continents passed the baton of observation. Chile handing off to Hawaii, Hawaii to the Canary Islands, then to space telescopes orbiting above Earth's atmosphere. The James Webb turned its infrared gaze on 3 I divided by Atlas, finding it dominated by carbon dioxide, strangely low in water vapor. The Very Large Telescope in Chile revealed bright nickel emissions, but curiously, no iron where iron should be. Hubble constrained its size, a modest nucleus just a few kilometers across, small yet potent enough to glow green in the night. Meanwhile, Swan R2 was dazzling amateurs and professionals alike, its brightness climbing, its tail stretching degrees of sky, larger in appearance than the moon. The science is meticulous. Photons split into spectra. Molecules identified. Cyanogen, diatomic carbon, water vapor, dust grains. Brightness curves plotted, tails measured, coma structures modeled. But beyond the graphs lies a story of human persistence. For centuries, the sky has whispered, and we have trained ourselves to listen more carefully each generation. Stone-carving priests once marked the paths of comets. Now algorithms catch them in pixelated anomalies. Yet the core emotion remains unchanged. Astonishment that something new has appeared, uninvited, in the firmament. The language of discovery is also the language of humility. The Atlas survey alone produces hundreds of gigabytes of sky, every clear night oceans of data where anomalies are drowned. Most are false positives. Asteroids, satellites, noise. Yet hidden among them, once in a decade, a true wanderer emerges. That we caught 3 divided by Atlas at all is a miracle of vigilance. How many others have passed unseen, their tails swallowed by glare, their secrets never recorded? How many messages slipped through the cracks of our watchful sky? The discovery of Swan R2 reminds us of something else. Science is not the sole domain of institutions. It was an amateur, gazing at swan imagery not for fame, but for love of the sky, who first noticed its sudden bloom. A reminder that the universe is democratic, that its wonders are open to any patient eye willing to look. Professional or amateur, silicon or human, the discovery is a shared act, a chorus of watchers. But discoveries are only beginnings. What truly unsettles is what happens next. Because as October draws near, these 2 bodies will dive into the sun's glare. Earth-based telescopes will go blind at the very moment the climax unfolds. Days, weeks, perhaps months of silence will follow, until they re-emerge, if they re-emerge at all. We will wait in the dark, left only with speculation and faith. And so imagination slips in where data cannot reach. If science is about what, imagination is about why. Why together? Why now? Is it merely 2 wanderers drawn by gravity and probability, or is there choreography here, a hidden script? Astronomers may resist the question, but the public does not. To ordinary eyes, this looks like dialogue, a scout and a fortress, a needle and a veil, converging in time and space. The story of discovery, then, is also the story of what we project. Some see a coincidence of ice and dust. Others see patterns, symbols, intention. Both interpretations reveal something fundamental not about the comets, but about us. We are creatures who crave meaning. We do not accept silence easily, and so, when 2 cosmic voices sing in the same octave, we hear not randomness, but harmony. Perhaps discovery is never complete until it becomes story. The machines find the pixels, the scientists find the orbits, but it is the human heart that makes sense of it. That is why 3 divided by Atlas and Swan R2 are more than objects. They are characters in a cosmic play, one green and small, the other grand and blazing. Their entrances now scripted into history, their fates unwritten. We, their audience, watch from a fragile blue world, waiting for the curtain of sunlight to rise again. For discovery is not only about knowing, it is about enduring the wait between knowing and not knowing. And in that space, we find the drama that makes the sky so endlessly human. Deep space speaks in the language of metals. Every atom carries a voice, every photon a signature. When the Very Large Telescope turned its eye toward 3 divided by Atlas, astronomers expected a familiar chorus: carbon, water, dust, and the faint echo of iron, as in every comet they had studied before. But what came back startled them. Nickel shone bright and unambiguous, yet iron, its eternal companion, was absent. It was as if a piano key had been struck without the rest of the chord, leaving a haunting dissonance in the music of the cosmos. To the casual observer, such subtleties are invisible. A comet's glow is just beauty in the night sky. But to scientists, that missing iron line is a riddle. In meteorites, asteroids, and other comets, nickel and iron walk hand in hand. They are forged together in the fires of stars, locked into predictable ratios by cosmic alchemy billions of years old. The absence of iron in 3, I divided by Atlas, is like hearing a familiar song with half its notes erased. The question reverberates. What could cause such a discord? Theories unfold. Perhaps exotic chemistry, in the interstellar medium-bound nickel, into fragile compounds, releasing it preferentially. As the comet warms near the sunday, perhaps eons of cosmic weathering altered its surface, stripping iron away. Perhaps the ratios in its home star system simply followed a different script, rewriting what we assumed was universal. But some whispers go further. Could this be a signature not of nature, but of design? Could we be staring not at an accident of chemistry, but at a fingerprint, subtle and deliberate? NASA and ESA remain cautious. Their statements emphasize the familiar, unusual, yes, unprecedented, no. Space is vast and diverse, and 3 known interstellar visitors hardly define what is normal, yet the strangeness lingers. Because chemistry is supposed to obey the grammar of physics, and here we see a dialect that does not quite fit the rules. As scientists dissect spectra, the public turns to imagination. The green glow of the comet becomes more than just cyanogen and diatomic carbon fluorescing under sunlight. It becomes a symbol, an emerald flame burning across the dark canvas of October nights. Photographers capture it, their lenses translating photons into images shared across the world. Children look through small telescopes and gasp. Amateur astronomers speak of it in reverent tones. In the language of human culture, green has always carried weight. Renewal, life, warning. To see it radiating from an interstellar stranger is to feel both promise and unease. Meanwhile, Swan R2 presents its own puzzle. It brightens too quickly, unfurling a tail as if racing to announce itself. Its outgassing follows patterns both familiar and slightly foreign, as though nature were repeating a theme in a new key. Together, the pair seem like opposites in dialogue, compact and needle-like, against vast and sprawling, subtle emerald against sweeping silver. And if the human mind is wired to find patterns, how can we resist seeing them as characters designed to complement each other? This is where drama enters. Data tells us nickel without iron. Imagination asks, why? Data shows us a brightening curve too steep. Imagination whispers, to what end? We stand at the threshold where science and speculation collide, not to dismiss one another, but to enrich. For even as we remain disciplined in observation, we cannot help but feel that something intentional hovers in these anomalies, like the faint outline of a message hidden in static. Consider the history of discovery. When Galileo first turned his telescope to the heavens, he saw moons orbiting Jupiter, something no one expected. When Newton calculated the motions of comets, he revealed a cosmos bound by mathematics rather than whim. When astronomers first found exoplanets, they discovered worlds orbiting in ways our models never predicted. Again and again, anomalies become revelations. Perhaps 3, I divided by Atlas, is another. Perhaps the missing iron, the dominant carbon dioxide, the green glow, perhaps all, are parts of a new grammar of creation that we are just learning to read. And yet, what if the anomalies are deliberate? That question haunts quietly, lingering in late-night discussions. If the universe is sprinkled with intelligences older and stranger than us, why not leave messages in the only medium guaranteed to last? Atoms, molecules, light. A civilization that can cross stars might not speak in words. It might speak in chemistry. It might place nickel where iron should be, green where black was expected. It might craft comets that masquerade as natural wanderers until one curious species begins to notice what is missing. Such speculation may exceed the data, but it captures the imagination. And in truth, imagination is as much a driver of science as skepticism. For without wonder, the instruments fall silent. Without questions, spectra are just numbers. And so, the drama of metals, the missing iron, becomes not just a puzzle for researchers but a spark for humanity. Look again at the night sky in October. See the emerald smudge of 3I divided by Atlas, the luminous veil of Swan R2. Behind those lights lie countless stories, scientific, cultural, philosophical. Some will say coincidence, others will say omen. A few will dare whisper of design, but all will agree on this. Something extraordinary is happening, and it will not be easily forgotten. In the end, the atoms do not lie. Nickel glows where iron does not. Carbon dioxide dominates where water should. Cyanogen paints green where we expected black. The universe is speaking in a dialect, strange and unfamiliar. Whether it is nature's dialect or someone else's, we have yet to decide. Picture the solar system as a grand clockwork. Each planet ticks in its orbit, steady and predictable, a cosmic ballet choreographed by gravity. For billions of years, this order has held, planets circling the sun like dancers tied to invisible strings. And then, October 2025 arrives. Into this ordered stage step 2 uninvited guests. 3I divided by Atlas, interstellar and retrograde, and Swan R2, native and flamboyant. They enter not from the same door, not even from the same tradition of birth. Yet their timing overlaps with uncanny precision. The probability, the statisticians say, is vanishingly small. Yet here they are, meeting in the golden theatre of the inner solar system. 3I divided by Atlas drifts, in from the direction of Serpent's Cauda, its orbit retrograde swimming upstream against the flow of planetary motion. To call it rebellious is no exaggeration. Its inclination of nearly 175 degrees makes it almost a mirror image of the rest of the solar family. No planet, no asteroid here behaves so defiantly. Swan R2, by contrast, tells a story closer to home. Born in the Oort cloud, it spent eons in frozen silence until some gravitational nudge sent it inward. Its orbit is elliptical, loyal to the sun's embrace, yet stretched almost to breaking. These two bodies could hardly be more different, one alien, one native, one small and needled, one vast and veiled. And yet, their closest encounters unfold within weeks of one another, as though rehearsed. Consider the timeline. Swan R2 sweeps around the Sun on September 12th, grazing within half an astronomical unit. On October 3rd, 3I divided by Atlas passes close to Mars, a mere 30 million kilometers away, giving the red planet a front-row seat. On October 21st, Swan R2 makes its closest approach to Earth, skimming within 40 million kilometers. And on October 29th, 3I divided by Atlas swings near the Sun, at 1.35 AU closer than any interstellar visitor we've ever recorded. 4 key milestones, compressed into 6 weeks, all visible within the span of human breath. If they were dice rolls, the odds would be staggering. If they were choreography, the elegance would be undeniable. Astronomers admit the unease. Some dismiss it as selection bias. We notice patterns because our minds demand them. In a universe with billions of comets, coincidences will eventually occur. But others confess the strangeness nags at them. To witness two cosmic strangers arriving together is like standing at a train station where two engines, from opposite directions, thunder in at the same hour. You can call it coincidence, yes, but your heart whispers, planned. From Earth, the drama is visual as well as mathematical. Swan R2 dominates the western twilight, its tail stretching up to 2 degrees across the sky. A tail so large it dwarfs the moon. A luminous veil sweeping against the darkness. 3I divided by Atlas, smaller, requires a telescope, yet its emerald tint sets it apart. One is spectacle, the other is enigma. Together, they write a contrast too perfect to ignore, a fortress and a scout, a cathedral of ice and a dagger of green, the poetry of juxtaposition, and yet, October brings not just revelation but concealment. As both draw closer to the sun, Earth's telescopes falter. Solar glare swallows them, leaving us blind during their most critical moments. The very act of convergence hides itself. Weeks of silence stretch ahead. Will they emerge as expected tales, ragged but intact? Or will they vanish, dissolved, consumed, or transformed? The uncertainty gnaws, for it is in those invisible weeks that the truth may reside. Mars, with its orbiting fleet of robotic sentinels, becomes our proxy witness. Cameras and spectrometers aboard orbiters will try to capture 3I divided by Atlas as it sweeps by. Perhaps those machines will see something our blinded telescopes cannot. Perhaps not. The risk is clear. Humanity may miss the climax entirely, left to interpret only the aftermath. It is like reading a novel with the final chapter torn out. What happens behind the curtain of the sun may never be known, but here speculation blooms. If two paths rhyme, is it poetry or plan? Theories multiply. Coincidence, choreography, conspiracy. The skeptical insist the dice of probability eventually fall this way. The dreamers ask, what if? What if Swan R2 is more than spectacle, and 3I divided by Atlas more than anomaly? What if their timing is not luck but message? The beauty of science is that it resists the leap too quickly. The beauty of humanity is that we leap anyway. We imagine stories, a scout and a fortress rendezvousing at the heart of the system, a hunter and a guardian circling in hidden conflict, a message sent and a reply delivered. Whether true or not, these narratives reveal our deepest trait. Faced with silence, we invent music. Faced with coincidence, we conjure meaning. As October 2025 unfolds, we live not just in the light of stars but in the shadow of questions. Will the emerald needle and the silver veil prove to be nothing more than ice obeying physics? Or are they part of something larger, something planned? Perhaps the answer lies in the weeks of silence, when both vanish into solar brilliance. In that absence, our imagination will burn brightest. And perhaps that, too, is the point. Human beings are pattern seekers. It is our gift and our curse. We see constellations in random stars, omens in the flight of birds, meaning in coincidences that could just as well be chance. When faced with two cosmic visitors arriving together, our minds instinctively weave stories. To scientists, the data points suggest rarity, but not impossibility. To the human heart, though, the convergence feels like design, and so theories spread like constellations across the night sky, each one connecting the same stars in different ways. One story paints 3I divided by Atlas as a scout fast, sharp, maneuverable, while Swan R2 becomes the fortress, vast and resplendent, carrying resources or signals hidden beneath its shimmering veil. If the scout hypothesis is true, then October is not chance but rendezvous, a meeting in the inner solar system, timed with mechanical precision, to gather intelligence or exchange information. To those who whisper such theories, Swan's blazing tail is not just ice and dust, but a veil for operations invisible to our instruments. Another theory suggests maintenance rather than reconnaissance. Imagine a galactic infrastructure older than humanity, with roots and cycles that span millennia. In this vision, Atlas and Swan are caretakers, arriving on schedule to refresh systems or collect data from hidden nodes scattered among the stars. Not invaders, not omens, just technicians on an ancient timetable. The idea is almost comforting, as though our sun were just one station on a vast railway where trains stop periodically to refuel and update. But darker visions creep in as well. Some frame 3I divided by Atlas as a predator, Swan R2 as either prey or guardian. Their convergence becomes a battlefield, hidden behind the glare of the sun where our telescopes cannot see. Others imagine Swan as a harvester, siphoning energy from the solar wind, while Atlas scouts for vulnerabilities. Still, others see them as a reply to our own message, our century of radio waves leaking into space, finally answered by emissaries of unknown intent. In the sterile corridors of observatories, scientists resist these leaps. Extraordinary claims require extraordinary evidence, they remind us. And the evidence, so far, remains consistent with ice, dust, and gas. Yet even within those walls, not all doubts are silenced. Harvard's Avi Loeb has spoken of technological signatures, pointing out that coincidences of timing deserve at least as much curiosity as anomalies of chemistry. He does not claim certainty, but he refuses to dismiss possibility. And that refusal has sparked both ridicule and fascination. For to entertain such ideas is to walk a tightrope between science and myth. Outside the labs, imagination roams freely. Social media explodes with speculation. Artists draw Atlas as a glowing spear piercing the sun, Swan as a radiant citadel unfolding wings of light. Ancient myths resurface comets as heralds of dynastic change, two lights in the sky as cosmic twins or rival gods. For some, it is not science but destiny, the heavens once again delivering a message at a turning point in history. But why does the human mind lean this way? Perhaps it is because randomness offers no comfort. If two comets simply arrive together by chance, then the universe is indifferent. But if there is purpose, then we are not alone. Theories, then, are not just explanations of the sky. They are mirrors reflecting our own fears and hopes. To see a scout and fortress is to imagine invasion. To see a relay and depot is to imagine contact. To see maintenance workers on a cosmic timetable is to imagine that our solar system is part of a greater design. The truth may be more ordinary, but speculation has its role. It keeps us watching, keeps us questioning. It is no coincidence that revolutionary discoveries in astronomy have often begun as anomalies dismissed by many and defended by a few. What if this October is such a moment? What if the stories are not merely myths but foreshadowing? As both comets vanish into the sun's glare, we will be left only with silence. And in that silence, imagination will reign. Perhaps when they re-emerge, they will be battered, ordinary, and our theories will fade. Or perhaps they will not re-emerge at all, leaving behind only questions. Either way, October 2025 will have carved itself into memory, not only as science, but as story. Because in the end, our theories are not about comets. They are about us. Our fear of being alone, our longing not to be, our refusal to accept randomness as enough. We paint constellations in chaos, not because the stars demand it, but because our hearts do. And so Atlas and Swan become more than ice and dust, they become canvases on which humanity projects its oldest hunger, the search for meaning. Every great discovery begins humbly with a flicker of light on a detector, with numbers scrolling across a screen. The story of 3I divided by Atlas is no exception. On a July night in 2025, in the dry, thin air of Chile's Atacama Desert, the Atlas Survey telescope noticed a single pixel that should not have been there. To most, it looked like a meaningless speck, another artifact in the endless flood of data. But algorithms flagged its motion, and within hours orbital mechanics confirmed the astonishing truth. This object was not bound to our Sunday. Its trajectory was hyperbolic. Proof that it had wandered in from the vast spaces between stars. Humanity had met only two such travelers before, Oumuamua and Borisov, and now here was a third. The discovery timeline revealed how close we came to missing it. By the time it was noticed, Atlas had already slipped past Jupiter's orbit, a silent interloper hiding in the glare of the sun for months. It may have been inside our solar system since late 2024, undetected, unnoticed, drifting like a shadow among the planets. That realization unsettles astronomers. If this visitor could cross our neighborhood unseen, how many others have done so? How many messengers have passed by without our knowledge, their secrets carried back into the dark? The object's trajectory is extraordinary. nearly retrograde, tilted at 175 degrees to the plane of the planets, swimming upstream against the current of the solar system. Its path will carry it inside the orbit of Mars, to a perihelion distance of just 1.35 astronomical units on October 29th. For an interstellar visitor, this is shockingly close. Its flyby of Mars on October 3rd will bring it within 30 million kilometers of the red planet, close enough for orbiters there to capture data Earth-based telescopes may miss. For Earth itself, the closest approach will remain a safe 270 million kilometers, but the opportunity for study is profound. Hubble's keen vision has constrained the nucleus to only a few kilometers across, modest in size, yet potent enough to generate a glowing green coma visible across autumn skies. The James Webb Space Telescope has already revealed a composition dominated by carbon dioxide, with surprisingly little water vapor at large distances. The Very Large Telescope in Chile has shown the now famous nickel emission lines, with iron conspicuously absent. Piece by piece, the portrait of Atlas grows stranger, as though this visitor refuses to conform to our models. Behind the numbers lies a human story. Teams across continents coordinate observations, handing the object from one hemisphere to another as Earth spins. Data flows through fiber cables like digital rivers, arriving in labs where weary scientists pore over graphs late into the night. The global collaboration is immense, amateurs feeding images into databases, professionals running simulations, algorithms scanning for patterns. It is a chorus of curiosity, united by a shared desire to understand this wanderer. And yet, as October approaches, the sky conspires against us. The geometry of Earth and Sun will soon make 3I divided by Atlas nearly invisible. Solar glare will blind our instruments during the most critical weeks of its approach. We may learn less than we hope, forced to wait until it re-emerges months later, if it re-emerges at all. That gap, that silence, becomes a canvas for fear and imagination alike. Perhaps the comet will behave predictably, its chemistry exotic but natural. Or perhaps it will shatter under solar heat, leaving fragments that tell a different story. Or, more provocatively, perhaps it will reveal behaviors no natural body should display. To the public, the narrative is already larger than science. They see Atlas not only as an object but as a character. It is the Green Scout, the interstellar messenger, a needle of emerald light threading through the solar system. They imagine it carrying data, or coded chemistry, or even intent. Whether or not such speculation holds truth, it reveals something essential, that discovery is never only about the object. It is also about us, about the stories we tell to bridge the gap between numbers and meaning. October 2025 will be remembered not just for its data sets, but for its drama. A pixel became a comet became a messenger, and a messenger became a mystery. In Chile, in Hawaii, in labs across Europe and America, scientists ready their instruments, racing the calendar. They know this is a once-in-a-lifetime chance. They know the silence of solar glare will come, and they know that whatever emerges in December may confirm their models or shatter them. 3I divided by Atlas is more than a wanderer. It is a reminder that the cosmos is not empty but alive, sending visitors across gulfs of light years. We watch it now, not with fear but with wonder, knowing that for a brief season we are witnesses to a drama billions of years in the making. The universe paints its stories not with words but with light. Every wavelength is a brushstroke, every glow, a sentence in a cosmic language older than Earth itself. As 3I divided by Atlas continues its approach, its strange colors demand attention. While most comets dazzle in icy whites or faint blues, this interstellar wanderer burns green, an emerald fire haunting October skies. The glow is not decoration, it is chemistry revealed. Molecules like diatomic carbon and cyanogen absorb solar radiation, then fluoresce, their electrons leaping and falling in quantum dances that emit green light. Yet here, the intensity is greater than expected, steadier, almost insistent. Scientists note the anomaly. Dreamers see a signal. Cyanogen, in particular, unsettles the imagination. On Earth, it is a deadly toxin, a compound associated with suffocation and fear. In the cold vacuum of space, it is something else, a marker of organic chemistry, a clue to the birthplaces of stars and the icy nurseries of planets. To know that cyanogen glows in Atlas's coma is to glimpse conditions from another system, far from ours, shaped by temperatures and pressures we can only guess at. Each photon from that green haze is a message billions of years old, whispering secrets about the star where Atlas was born. The nickel puzzle deepens this portrait. Astronomers expected iron to join nickel in the spectral lines, as it does in every meteorite and comet known. Yet the iron is silent, absent as if erased. Explanations remain tentative, exotic compounds breaking down, long eons of cosmic weathering, chemical pathways unique to Atlas's home system. But the strangeness persists, a note of dissonance in the music of elements. Some theories venture further that this imbalance could be artificial, engineered rather than natural. NASA dismisses such claims, reminding us of our bias toward agency. Yet history whispers caution. How often have anomalies dismissed as noise turned out to be the first notes of revolution? Swan R2, too, has its peculiarities. Its brightening was too rapid, its tail development too dramatic. It behaves like a comet, and yet just differently enough to make astronomers furrow their brows. The contrast between the two, Atlas compact and sharp, Swan sprawling and magnificent, creates a visual poem. One emerald flame, one silver veil, one mysterious and alien, one familiar yet uncanny. Together they form a duet, a yin and yang suspended in the heavens. For ordinary people watching from the ground, chemistry is irrelevant. What matters is beauty. Children see a green star blooming where none was before. Photographers frame Swan's tail stretching across the horizon, painting nightscapes that resemble myths more than science, and myths indeed resurface. In ancient cultures, comets of strange colors were warnings, portents of change. A green light in the sky could mean death of a king, plague, or the arrival of a god. Today, we know better, or so we say. Yet the emotional impact is the same. To stand under Atlas's emerald glow is to feel the weight of history pressing from both past and future, as if we are repeating rituals of awe our ancestors knew well. Scientific rigor does not cancel wonder, it sharpens it. Each molecule identified is not a reduction, but an expansion of mystery. When the Very Large Telescope plots emission lines, when the James Webb measures carbon dioxide dominance, we are not closing doors, we are opening them, peering into conditions beyond Earth's cradle. The chemistry of Atlas is exotic, yes. But exotic is not the same as extraordinary. Or is it? That is the line scientists tread, balancing between caution and imagination. And imagination is hungry. Already, the green glow has become symbolic. Poets write of it as a beacon. Artists render it as a lantern in the void. Some conspiracy theorists declare it a probe. Its glow, an intentional broadcast. Others, more quietly, see in it a metaphor for humanity itself. Small, fragile, green like our planet, wandering through darkness yet visible from afar. The drama of chemistry is also the drama of perspective. To an astronomer, Atlas is a laboratory, a place where exotic molecules reveal clues to stellar formation. To a philosopher, it is a text, an alien script written in gas and light. To an ordinary family watching from their backyard, it is a memory etched into childhood. I remember the green comet. Each view is true, each incomplete. The comet exists beyond all our interpretations, and yet it only exists for us through them. And still, questions multiply. If diatomic carbon is the culprit, why is the emission so strong, so consistent? If cyanogen plays a role, why does it dominate the spectral portrait so visibly? If nickel shines without iron, what story does that imbalance tell? The universe rarely answers quickly. More often, it keeps speaking in riddles until we learn the language. For now, the language of Atlas is emerald, the accent of its syllables metallic and strange. It tells us that not all comets are alike, that not all systems obey the same rules, that chemistry itself carries memory. Whether natural or intentional, the message is the same. Difference matters. And in that difference lies discovery. October 3rd, 2025. On that day, Mars, our rust-red neighbor, becomes the front-row witness to a meeting millions of years in the making. 3I divided by Atlas will sweep past the planet at a distance of roughly 30 million kilometers, close enough that its orbiters, designed to study Martian weather and geology, will suddenly find themselves tasked with observing an interstellar stranger. The encounter is distant by human standards, 5 times farther than the Earth, moon gap, yet in cosmic terms it is intimate. For an object that has traveled light years through interstellar space, brushing past another world feels like fate. The European Space Agency has already prepared. The Trace Gas Orbiter, circling Mars in silence, will turn its spectrometers outward, away from the planet it was built to study, toward the emerald-tinted wanderer. Mars Express, veteran of 2 decades, will join, recording images of the expanding coma and perhaps details of the dust trailing in Atlas's wake. Even NASA's Mars Reconnaissance Orbiter, with its legendary high-rise camera, may attempt to catch a glimpse. Though the comet will appear as a point source, its tail may reveal secrets invisible to Earth-based instruments. For scientists, this encounter is priceless. Earth's telescopes will soon be blinded by the sun's glare. Mars, by chance of orbital geometry, stands in a better position. Its instruments, free from Earth's atmosphere and closer to the visitor's path, may capture what we cannot. The irony is striking. Our quest to study Mars as a possible second home for humanity now allows Mars itself to serve as our scout, our surrogate eyes in the October darkness. But opportunity comes with challenge. Mars orbiters were never designed for this. Their cameras point down, toward dust storms and valleys, not toward icy wanderers in deep space. Mission teams scramble to reprogram them, to adjust pointing mechanisms, to calculate exposure times, data storage, communication bandwidth, power. All are limited, rationed carefully. Observing Atlas means sacrificing other priorities, a gamble taken in the name of curiosity. If successful, what might we see? Dust particles scattering sunlight in patterns that reveal their size, spectral lines hinting at volatile gases released as the comet warms, perhaps the first detailed look at the interaction between an interstellar visitor and the solar wind, seen from a vantage point no human eye can claim. Every photon recorded could rewrite textbooks, could sharpen the blurred outlines of Atlas's origin story. And yet, drama hovers here as well, for the Mars flyby is not just a scientific event, it is a narrative moment. Imagine the red planet, itself a symbol of exploration and longing, becoming the silent witness to a traveler from beyond the stars. Our robotic ambassadors orbiting it, machines built by human hands, suddenly stand at the threshold of interstellar mystery. They do not know awe, but we, their creators, do. Through them, we reach further than we ever imagined. Still, the uncertainties are sobering. At 30 million kilometers, even high-rise cannot resolve the nucleus. No surface features will be seen. No fine structures mapped. The comet will remain, as it always has, a luminous smudge. Dust storms on Mars might obscure data. Communication windows might delay the return of observations for days or weeks. It is possible that the most dramatic outbursts, the violent jets of gas, the sudden fractures of ice will happen outside the narrow window we can record. But speculation thrives on what-ifs. What if the green comet brightens unexpectedly as it nears Mars? What if it reveals anomalies no natural body should display, bursts of light too regular, emissions too structured? What if, in that brief encounter, Mars's orbiters capture something extraordinary, hidden from Earth's blind eyes. Such thoughts are not predictions, but they keep the watching alive, the sense of anticipation taut. The Mars flyby, then, is more than a scientific checkpoint. It is a test of perspective. Will we see only dust and spectra, or will we allow ourselves to feel the deeper resonance that a wanderer from another star has chosen to pass near a planet humanity dreams of colonizing? It is as though the cosmos, without intention, or perhaps with it, has staged a moment, a bridge between our future and the universe's past, between our ambition and the mysteries that humble us. When October 3rd arrives, scientists will watch their data streams. Amateurs will point telescopes skyward, though they cannot share Mars's vantage. The rest of us will simply wait, knowing that machines orbiting a world millions of kilometers away are standing in for our eyes. And in that waiting, we will imagine Mars itself, watching too silent, red, ancient, bearing witness to the emerald messenger that brushes by on its way to the Sunday. While 3I divided by Atlas carries the allure of the alien, it is Swan R2 that steals the stage with sheer spectacle. Emerging from solar glare in September 2025, it appeared suddenly, as though conjured from dawn itself. By mid-month, amateur astronomers reported its brilliance spreading across the western horizon. Its tail stretched degrees across the sky, luminous enough to paint twilight with silver strokes. Where Atlas was a subtle emerald smudge requiring careful searching, Swan R2 was a revelation, a comet made for poetry as much as for science. Its discovery story carries a distinctly human touch. Not NASA, not ESA, but an amateur named Vladimir Bezugli first noticed the anomaly, his patient eyes scanning the Swan instrument's imagery from Soho. There, amid streams of hydrogen data, a brightening betrayed a new comet. Swan R2 became official on September 11th, but it had already begun to announce itself. Its brightness climbed steadily, defying the modest expectations astronomers initially set. By late September, binoculars sufficed. By October, it brushed the edge of naked eye visibility. For millions across the globe, Swan R2 was not a line in a scientific paper, but a presence in the evening sky, an ornament of autumn. And yet, it was not just beauty. Its tail immense, ghostly told a story of furious chemistry. As Swan R2 swept within half an astronomical unit of the Sun on September 12th, solar heat stripped its frozen surface. Dust and gas erupted, filling space with an expanding veil millions of kilometers across. Hydrogen atoms, torn from water vapor by ultraviolet light, spread outward, their glow captured by the Swan instrument that lent the comet its name. The brightness, the tail length, the rapid evolution, all these became puzzles. Why did it brighten so quickly? Why was its display so dramatic compared to other Oort cloud comets? The questions multiplied, even as the comet grew more magnificent. Observers described its tail as reaching 4 times the width of the Moon's disk. Some reported structures disconnections, kinks, where the solar wind wrestled with its ion stream. Photographers captured scenes that looked painted. Swan hovering near the bright star Spica in Virgo, its silver plume arcing against a velvet sky. For a brief season, the comet transformed ordinary backyards into observatories and ordinary stargazers into witnesses of cosmic grandeur. But Swan R2 is not only a spectacle, it is also a companion in October's duet. While Atlas lurks smaller, greener, stranger, Swan roars across the sky as if declaring itself the herald. One whispers, the other shouts. One hides its secrets in chemistry, the other displays its beauty for all to see. Together, they form a pairing too dramatic for chance alone, or so human imagination insists. The scout and the fortress, the dagger and the veil. Science says they are unrelated. Storytelling says otherwise. The cultural resonance is powerful. Across history, comets have been read as warnings, omens of upheaval. In medieval Europe, chroniclers blamed comets for plague and war. In China, they were guest stars, intruders in the ordered heavens. Swan R2, blazing in the same season as 3I divided by Atlas, revives those ancient reflexes. Newspapers write of cosmic coincidences. Social media buzzes with speculation. Artists and musicians borrow the imagery of twin comets, one green, one silver, as metaphors for duality, for arrival, for destiny. Scientifically, Swan R2 is a gift. Unlike Atlas, it is bright, large, and close, making it easier to study. Its perihelion passage and near-Earth approach on October 21st bring it within 40 million kilometers, close enough to allow detailed spectroscopy, imaging, and analysis. For astronomers, it is a rare chance to compare a native comet with an interstellar one, side by side, under similar solar conditions, to understand how environment shapes behavior, how formation conditions determine chemistry. The timing is extraordinary, a natural experiment orchestrated by the cosmos itself. But for all the science, the drama persists. Swan is not just data, it is experience. People stop in streets, tilt their heads, and for a few minutes forget the noise of earthly life. A comet's tail, spanning millions of kilometers, reminds us that scale is relative, that our concerns are small against the backdrop of stars. Swan R2, in its luminous sweep, becomes a kind of mirror. In it, we see our hunger for beauty, our yearning for story, our need to believe that coincidence is never merely coincidence. By October's end, Swan will fade, its tail dispersing into interplanetary space, its brilliance softening. It will retreat into the archives of astronomy and the memories of those who watched. Yet for a season, it stood as the new giant, the herald to Atlas's enigma, reminding us that the sky is not silent but alive, and that sometimes two voices sing together when we least expect it. Speculation often lives in the shadows cast by science. Where data ends, imagination begins. With 3I divided by Atlas and Swan R2, the line between natural and engineered phenomena becomes the stage for some of the boldest theories ever whispered in astronomy. To most scientists, comets are icy leftovers, shaped only by gravity and heat. But to those who dare to ask, what if? The unusual chemistry, the precise timing, the choreography of their arrival suggest possibilities stranger than fiction. First comes propulsion. Natural comets are passengers, their paths carved by the sun's gravity. Yet some wonder, what if Atlas is not drifting, but steering? If a plasma drive or ion engine guided its course, would we even recognize it? Subtle acceleration might mimic outgassing, the thrust hidden within the noise of sublimating ice. A truly advanced system could disguise itself perfectly, masquerading as cometary physics while plotting a chosen trajectory. Thus far, no anomalous thrust has been detected, but silence does not always mean absence. Then there is shielding. Comets naturally grow comae and ion tails, plasma clouds that deflect the solar wind. But what if those clouds are more than passive physics? An electromagnetic field, deliberately generated, would look remarkably similar. To our instruments, it would be just another ion tail. To its creators, it could be a shield against radiation, or even a communication medium hidden in plain sight. The thought unsettles. Could technology cloak itself so well that we would call it natural, simply because we cannot prove otherwise? Orbit, too, invites speculation. If these objects were truly artificial, we might expect patterns, repeat visits, coordinated arrivals, synchronized timing. 3 interstellar visitors since 2017 do not yet form a pattern, and yet the October 2025 convergence presses the question. 2 visitors, so different, appearing in the same season, is this merely the dice of probability, or is it a signature of intent? The relay hypothesis grows from this doubt. What if Atlas is a courier, Swan R2 a depot? What if one carries data across light years, while the other transmits it onward, using the sun's energy? A network of relays scattered through the galaxy would require no crew, no drama, just patience and physics. Each arrival could be part of a schedule we cannot see, a timetable set by civilizations long gone, their machines still performing tasks millions of years later. The harvest scenario offers a more ominous lens. The sun, after all, is not only a source of warmth for Earth, it is an engine, pouring out unimaginable energy. What if comets are not wanderers but collectors? Swan's vast tail could conceal magnetic funnels, channeling solar wind into storage systems. Atlas, smaller and sharper, could be the scout, measuring plasma conditions for optimal extraction. To us, they appear as ice sublimating. To others, perhaps, as industry camouflaged in natural form. Skeptics answer, extraordinary claims demand extraordinary evidence. And the evidence so far: spectral lines, brightness curves, orbital mechanics, fits within the boundaries of nature, however exotic. Nickel without iron can be explained by rare chemistry. Green emission can come from diatomic carbon. Rapid brightening can follow from fresh ice suddenly exposed. These are mysteries, yes, but not miracles. Yet speculation persists because imagination is not optional. It is woven into human inquiry. When Galileo saw Jupiter's moons, some imagined them as alien worlds. When Percival Lowell sketched Martian canals, he dreamed of civilizations. When astronomers first saw radio bursts, they half joked about extraterrestrial beacons. Each time, imagination ran ahead of data. Each time, science eventually caught up, correcting or confirming. Perhaps Atlas and Swan will be no different. Perhaps in December, when they re-emerge from solar glare, we will sigh with relief. They were only comets, after all. But what if not? What if one day, amid the noise of outgassing, we detect a signal too structured to dismiss? What if nickel lines form a code, if brightness curves reveal a pattern, if timing itself is the message? Even NASA admits the limitation. Absence of evidence is not evidence of absence. Our instruments may not be tuned to recognize technologies that operate beyond our physics. A machine advanced enough might mimic nature so flawlessly that we never know. For now, speculation is theater unproven, imaginative, alluring. But theater has value. It keeps us watching, keeps us asking questions we might otherwise ignore. And if the sky truly is staging a play, then Atlas and Swan are its lead actors, their roles shifting between wanderers, scouts, harvesters, and fortresses depending on who interprets the script. October 2025 will not end the debate. It will only sharpen it. For when the comets vanish into the sun's glare, silence will replace certainty. And in that silence, theories will multiply like stars, reminding us that the boundary between science and story is not a wall but a bridge. What could they possibly share? On the surface, 3, I divided by Atlas and Swan are 2, are worlds apart. One comes from interstellar space, lean and emerald, a traveler that has crossed the void between stars. The other is a native child of the Oort cloud, immense, flamboyant, carrying a silver veil across the heavens. Yet, as October 2025 unfolds, their arrivals overlap like lines of a poem. It feels less like chance, more like design. And so the question emerges, do they have a shared purpose? Human minds rush to fill the gap. We imagine Swan R2 as a depot, massive and resource-rich, while Atlas plays the nimble scout, darting ahead to probe conditions and carry information back. In such a framework, their rendezvous is no accident but a mission. The scout gathers intelligence, the fortress processes it. The veil of dust and gas conceals systems far beyond our comprehension. It is science fiction, yes, but it is also a story that clings to the imagination, refusing to let go. Another version sees them not as partners, but as counterparts in a cosmic surveillance grid. Perhaps ancient civilizations seeded the galaxy with monitors, disguising them as comets, each programmed to awaken when signs of technology emerge. Earth's radio waves have been leaking into space for a century. Could they be the trigger? Could Atlas and Swan be responses, automated messengers converging on our sun to process and relay what they have heard? The thought is haunting. We may not be ignored, we may be under observation. Others envision more primal dynamics, hunter and harvester. Atlas the scout, precise and fast, identifying targets. Swan the processor, vast and capable, harvesting energy or resources. In this darker view, October 2025 becomes less about discovery and more about extraction. Not communication, but commerce. The sun, in this scenario, is not just a star, but a refueling station. To humanity, this is unsettling. To a civilization millions of years older, it might be routine. Yet, another interpretation imagines them as guardians and predators locked in opposition. If Atlas is dangerous, Swan may have arrived to neutralize it. Or perhaps the reverse. Atlas carries the scalpel, Swan provides the shield. We do not know, because we cannot see. The sun itself becomes curtain and stage, hiding their true roles behind its blinding glare. The absence of data feeds imagination more powerfully than data ever could. To scientists, these ideas are speculation, fantasies born of coincidence. But to ordinary people, they are myths, reborn in a modern sky. Every culture has told stories of twin visitors, rival gods, siblings locked in eternal struggle, messengers arriving together at turning points in history. The Greeks told of Castor and Pollux, stars bound together as protectors. The Dogon of Mali spoke of paired celestial guides. In Europe, comets preceded the deaths of kings. October's duet is not the first time humanity has read meaning into the heavens, and it will not be the last. Still, the question of shared mission lingers, even for scientists. For while each anomaly can be explained nickel without iron, rapid brightening, timing, coincidences, the clustering of events stretches the fabric of probability. To see two objects, so different, arriving so close in time, is a reminder that nature itself can feel choreographed. And when nature feels choreographed, human imagination steps forward to supply intent. The truth may be simple. The two comets share nothing more than the sun's pull. They converge because gravity allows it, not because purpose demands it. Yet the truth may also be layered. What if intention hides within coincidence? What if coincidence is the camouflage of intelligence? Such questions cannot be answered by data alone. They belong to philosophy, to poetry, to the restless human urge to find meaning. And perhaps that is their shared purpose, not in themselves, but in us. Together, they compel us to look harder, to question more deeply, to imagine more boldly. Atlas and Swan force humanity to confront its place in the cosmos, alone or observed, random or significant. They remind us that discovery is not only about objects, but about what those objects awaken within us. When October ends and the comets fade, we may discover nothing extraordinary in the data. But the memory will remain. Two lights, two strangers, two questions arriving at once. If nothing else, their shared mission has already succeeded. It has made us wonder. Among the boldest ideas born of this cosmic duet is the relay hypothesis. It imagines that 3I divided by Atlas is not merely an interstellar wanderer, but a courier, a messenger carrying compressed data gathered during its long journey between the stars. Swan R2, in this vision, is not simply a luminous veil of dust and ice, but a receiving station, a transmitter disguised as spectacle, harnessing the sun's energy to amplify and send information onward. The timing of their convergence then becomes purposeful, the fulfillment of a schedule written long before humanity ever learned to gaze at the heavens with telescopes. The logic of such a theory appeals to both scientists and storytellers. Our sun is not just a gravitational anchor. It is a vast power source, an amplifier, a potential hub. General relativity tells us that stars can act as natural lenses, focusing electromagnetic signals across impossible distances. Place a relay at just the right position near a star, and suddenly interstellar communication becomes feasible. In this framework, Swan R2 could be camouflaging a colossal antenna within its coma, while 3I divided by Atlas arrives to deliver the payload observations, updates, archives, collected across its voyage. Science fiction? Perhaps. But one must admit the elegance of the idea. Humanity itself has long dreamed of galactic networks, of probes sent to the outer reaches, of machines that continue their mission long after their makers are gone. Why should others not have dreamed the same? Why should they not have seeded space with messengers wrapped in the disguise of ice and dust, a camouflage that ensures their survival for eons? Of course, skeptics remind us of reality. No anomalous radio signals have been detected from either object. No acceleration betraying propulsion, no structured pulses hidden in their light. The data we have is exotic but not impossible. Nickel without iron, carbon dioxide dominance, rapid brightening. All explainable by natural physics, however unusual. Extraordinary claims, they say, still lack extraordinary evidence. And yet, the human mind hungers for more. We imagine 3I divided by Atlas, shedding molecules not as sublimation but as inscription, writing data into chemical trails. We imagine Swan R2's tail not as debris but as a colossal screen, a plasma canvas where information is encoded in magnetic whispers. We imagine the sun itself as the third partner in this operation, its plasma winds carrying messages outward to listening posts scattered like sentinels across the galaxy. History warns us to be cautious. Lowell's Martian canals turned out to be illusions. Pulsars were once labeled LGM, little green men, before we understood their neutron cores. Yet history also reminds us that anomalies often reveal revolutions. The discovery of exoplanets, the realization of black holes, the detection of cosmic microwave background radiation. Perhaps October 2025 is another hinge, where speculation today becomes understanding tomorrow. Even if the relay hypothesis is never confirmed, it serves a deeper function. It frames our place in the cosmos, not as bystanders but as participants in a conversation. If these comets are couriers, then we are the audience whether or not the message is meant for us. If they are natural, then they still perform a kind of relay. They carry chemistry across space, from one star system to another, depositing clues about their origins in spectra we can read. Either way, information travels, knowledge is shared, and humanity learns. For the ordinary person gazing up in October, the relay hypothesis translates into a simpler feeling, the sense that the sky is alive with intent. To see two comets at once, to know one comes from beyond the sun's domain, is to feel as if the universe is speaking, even if we do not yet know the language. And perhaps that is enough. Wonder itself is a kind of message, and curiosity a kind of reply. When Atlas and Swan vanish behind the sun, we will wonder if something passes between them in the silence we cannot penetrate. When they re-emerge, battered or intact, we will search their spectra for signs. Likely, we will find only physics, but possibly, just possibly, we will glimpse more. For if October 2025 is a relay, its greatest transmission may not be between comets or across stars. It may be within us, a relay of imagination, a passing of awe from one generation to the next. To look up at a green smudge and a silver veil and feel both curiosity and humility, that is the message we have already received. Imagine the sun not as the familiar star that warms Earth, but as a furnace coveted by others. For billions of years it has burned with relentless power, fusing hydrogen into helium, releasing energy so immense it outshines comprehension. Every second, 4 million tons of mass vanish into light. To us, the sun is life. But what if, to others, it is fuel? This is the heart of the harvest scenario, a vision where Atlas and Swan are not wanderers but workers, their arrival part of a cycle of cosmic resource extraction. In this framework, 3I, divided by Atlas, plays the role of surveyor. Small, sharp, green a scout, measuring plasma densities, solar output, magnetic field geometry. Swan R2, immense and dazzling, unfurls its magnificent tail not as a passive byproduct of sublimation but as a collection system. Imagine its dust veil as engineered funnels, capturing charged particles from the solar wind, siphoning isotopes like helium-3, the prized fuel for fusion reactors humanity has yet to master. From Earth, we see beauty. From another perspective, it could be industry disguised as natural wonder. Science explains tales as sunlight pushing on dust, as ions carried by solar wind. Yet harvesting could mimic this perfectly. A technology advanced enough would not oppose physics, but ride upon it, enhancing natural flows with subtle control. To us, it would look like sublimation. To them, it would be machinery operating in camouflage, indistinguishable from what we expect. Arthur C. Clarke's adage resonates here. Any sufficiently advanced technology is indistinguishable from magic. Perhaps it is also indistinguishable from nature. The scenario stretches imagination further. Micro, wormholes stabilized in stellar fields, conduits through which harvested matter could be whisked across interstellar distances, or magnetic reconnection harnessed to channel plasma into reservoirs hidden within cometary cores. The very phenomena we interpret as cometary outbursts might, in such a framework, be controlled discharges, the byproducts of stellar farming. Science has no evidence of this, but speculation thrives because the possibility cannot yet be disproven. History teaches us that humans, too, are harvesters. Our ancestors followed herds, then tilled fields, then mined coal and drilled oil. We move from forest to savanna to star, always in pursuit of energy. If civilizations older than ours exist, why would they not expand their hunger outward? Stars, after all, are the ultimate resources, and comets, abundant and mobile, would be the perfect camouflage for machines assigned to gather and transport what stars provide. For astronomers, Swan R2's brilliance is already suspicious. Its tail spans millions of kilometers, so vast that it rivals planetary scales. It dwarfs the moon's diameter in the sky, a shimmering veil whose scale boggles the imagination. To see such a structure is to feel awe, but also to wonder, what if this vastness is not excess but design? What if size itself is the function, the mechanism by which a cosmic harvester performs its task? The darker implication unsettles. If our sun is a gas station on a galactic network, then humanity's presence here may be incidental. Our planet orbits a resource hub not because it is unique, but because it is convenient. What rights, then, do we hold? Are we owners or simply tenants? If the harvest scenario were true, then October 2025 is not a coincidence, but an appointment kept, a schedule older than civilization, older than Earth's empires, older perhaps than Earth itself. Of course, mainstream science resists such leaps. Every spectral line, every outburst of gas, fits within known cometary physics. Nickel without iron, cyanogen green, carbon dioxide dominance, all exotic, but all explainable. No measurements demand harvesting, yet absence of necessity does not erase possibility. The cosmos does not owe us simplicity, and the veil of Swan R2 leaves room for interpretations both humble and unsettling. For ordinary people gazing upward, the harvest scenario is not physics, but metaphor. They see Swan's tail sweeping the sky and imagine brooms, nets, collectors. They think of Earth's endless appetite for energy, and they project it outward. The harvest scenario, then, reflects less about comets and more about us. It reveals our fear that we are not alone, and our suspicion that if we are not, others may not be benevolent. Whether true or not, the scenario forces us to reframe the sky, to ask not only, what are these visitors, but why do they come here at all? And if October is harvest, then perhaps the Emerald Scout and the Silver Fortress are not anomalies but workers fulfilling a destiny far beyond our comprehension. As comets become headlines, the world reacts in ways both familiar and surprising. Newsrooms race to package images into clickable moments. Anchors speak in hushed, urgent tones. Pundits frame the event as proof of everything from human insignificance to cosmic destiny. Politicians use the spectacle to score points. Some promise funding for space programs. Others denounce alarmism. Religious leaders offer sermons. For some, the sky is a sign. For others, a reminder of humility before creation. In city squares and rural plazas alike, people gather with phones and binoculars, translating photons into communal ritual. Scientific institutions feel the pressure. Funding agencies receive an influx of requests to reallocate resources. More telescope time, emergency telemetry, rapid response missions. Space agencies convene meetings, their calendars crowded with coordination calls across time zones. Observatories reprioritize schedules, sometimes canceling other programs to track the comets. The scramble is both exhilarating and inefficient data. Pipelines are overloaded. Engineers burn midnight oil to rewrite software that expects months, not days, to adapt. International teams set up urgent networks to share raw data, but bandwidth and proprietary systems complicate the flow. Collaboration becomes improvisation. Not all responses are scientific. Stock markets twitch at headlines. Companies with ties to satellite imaging see their shares ripple. Philanthropists pledge funds to universities. Think tanks publish op-eds about planetary defense and cosmic policy. The notion that humanity might share its neighborhood with engineered objects spawns policy debates. Should there be an international protocol for responding to suspected technological artifacts? Who decides when to label something anomalous enough to warrant diplomatic attention? The questions force diplomats into scientific conversations they once avoided, revealing gaps in legal frameworks built for a different age. Misinformation floods the channels. A single blurry photo can spiral into 1,000 variations, each more elaborate than the last. Conspiracy accounts claim governments are hiding recovered fragments. Influencers stitch together satellite imagery and grainy footage into cinematic narratives that go viral. Social media platforms scramble, toggling fact-check labels and promoting authoritative sources, but the viral engine outpaces moderation. Scientists and communicators find themselves not only doing research but also performing public education, holding live stream, Q and As, posting explanatory threads, and sometimes appearing on late-night shows to calm fears. Religious communities respond with a spectrum of interpretations. In some churches and mosques, sermons emphasize stewardship, our duty to care for Earth, in a universe that is larger than we imagined. Other groups interpret the events as signs of an imminent shift, calling for repentance or prayer. Indigenous leaders remind audiences of traditional sky knowledge, offering ceremonies that ground the event in millennia of human skywatching. These responses reveal that for many, science and faith are not opposites but different languages describing the same awe. Politically, the event becomes a stage. Countries with active space programs highlight their capabilities, broadcasting images and releasing preliminary data as proof of national prowess. Smaller nations without orbital assets find themselves barred from the front lines of observation, raising questions about scientific equity. International collaborations form, some formal, some ad hoc. Data sharing agreements are negotiated at extraordinary speed. For the first time in many years, there is a global scientific sprint that resembles the cooperative achievements of the Apollo era, but powered by distributed networks of amateurs, universities, and private companies, as much as by national agencies. Amid the noise, the SETI community watches closely. Radio observatories dedicate time to scanning the comets for narrowband signals. Optical astronomers search for periodic flashes. The search is cautious and methodical, professionally skeptical but unable to ignore the stakes. Any structured signal would upend assumptions about humanity's place in the cosmos. Yet decades of scanning have taught caution. The universe offers many natural mimics. False positives will come. Careful verification is essential. The protocols the community uses, multiple independent detections, cross-instrument confirmation, become the backbone of responsible speculation. Meanwhile, artists and writers find inspiration. Galleries mount comet-themed exhibitions. Writers draft essays about smallness and grandeur. Musicians compose ambient pieces inspired by the emerald glow and silver veil. The event becomes a cultural catalyst, translating photons into stories, music, and paintings. Composers layer recordings of radio telescope noise into tracks that mimic cosmic winds. Visual artists use long-exposure photographs to paint ghostly veils. The comets enter human culture not as raw data, but as metaphors, symbols for moments when the ordinary is interrupted by the sublime. Technologists and engineers take a different view. Startups pitch ideas. CubeSat constellations for rapid comet interception, machine learning systems to parse outgassing signatures, and small kinetic impactors designed to test cometary response. Universities call for grant proposals. In laboratories, students code feverishly, eager to contribute to the global effort. The comets, in that sense, catalyze innovation, accelerating projects that might otherwise have taken years to gain traction. Even long-term initiatives, planetary defense architectures, improved wide-field surveys gain political traction and budget attention overnight. At the personal level, reactions are quietly human. An old man in a seaside town recounts watching Halley decades before and now shares binoculars with his granddaughter. A teenager in Lagos records Swan R2 with a phone, her clip accumulating thousands of likes. Families host impromptu stargazing nights. Neighbors lean across fences to point out the green smudge. In moments like these, technology and spectacle retreat, and communal wonder reasserts itself. The sky, for a while, becomes a shared room where strangers meet. But beneath the warmth lies anxiety. Governments debate contingency plans. What if a comet fragments and creates meteor storms? What if a fragment intersects an orbital satellite? These are low probability but high consequence scenarios. Space situational awareness teams run simulations, updating collision risk assessments. Insurance companies reassess policies. Airlines consult space weather forecasts. Supply chains built on geostationary satellites begin to imagine cascading failures. The world, suddenly conscious of its vulnerability, begins to imagine the cascading effects of celestial events on modern life. Education systems adjust too. Teachers seize the moment, turning comet images into lessons about orbital mechanics, spectroscopy, and critical thinking. Libraries host community nights. Informal science educators translate jargon into wonder for children. The event becomes a teachable moment, an opportunity to raise scientific literacy even as misinformation spreads. Ultimately, the cultural response is a mirror of ourselves, a mix of curiosity, fear, creativity, and governance. The comets force us to ask not only scientific questions but social ones. Who gets to look? Who gets to decide? How do we manage truth when speculation runs faster than verification? The duet of 3I divided by Atlas and Swan R2 is as much a human event as an astronomical one, exposing the structures that bind societies together and the fault lines that could pull them apart. When the comets vanish into the sun's glare, we are left with absence, and absence can be louder than presence. For weeks in October and November 2025, Earth's telescopes will be blinded. Solar radiation drowns sensors, coronagraphs saturate, and the very moment of greatest drama is hidden from us. The curtain drops just as the performance reaches its climax. It is as though the universe has scripted a play, but denies us the final act. That denial gnaws at human imagination. We know the physics. Comets approaching perihelion can disintegrate. Solar heating fractures their fragile nuclei. Jets erupt. Tails disconnect and reform. Sometimes they emerge battered but intact, dimmer, yet still alive. Sometimes they vanish entirely, leaving only debris. The outcome is uncertain, and that uncertainty is its own fuel, because in the silence of observation, the human mind invents stories. Some envision Swan R2 breaking apart spectacularly, scattering across the inner solar system in a shower of fragments that will paint the night sky for weeks. Others fear catastrophic disintegration, its glory extinguished without a trace. For Atlas, the speculations run darker. Its chemistry is odd, its orbit retrograde, its behavior unpredictable. Some whisper of cloaked maneuvers, of transformations unseen. In the absence of data, rumor becomes as powerful as fact. The silence also becomes a test of patience. Scientists prepare protocols for re-emergence. The Solar and Heliospheric Observatory will track what it can. Space-based instruments like Parker Solar Probe and Solar Orbiter may catch glancing data during perihelion, though not enough to solve every mystery. Earth's ground-based observers will wait until December, when geometry shifts and glare recedes. Until then, speculation runs unchecked. Historically, such disappearances have shaped mythology. Ancient sky watchers feared comets swallowed by the sun, reborn later as omens of dynastic change. Medieval chroniclers spoke of Death Stars consumed in celestial fire, only to rise again transformed. October 2025 echoes those myths. We are no longer farmers fearing harvest omens, but our instruments cannot erase our imaginations. When the sky hides from us, we revert to ancient instincts, to invent, to warn, to hope. The emotional weight is profound. Communities that gathered nightly to watch the twin visitors must now confront an empty sky. Social feeds that once glowed with comet photographs fall quiet. The nightly ritual of pointing telescopes is replaced by waiting. Silence becomes the shared experience. Humanity, scattered across continents, shares not images, but anticipation. For perhaps the greatest drama is not what we see, but what we do not. Governments feel the silence too. Space agencies prepare press releases with hedges, if intact, if re-emergent, should the comets survive. Financial markets twitch at uncertainty, conspiracy theorists thrive. The gap becomes fertile ground for both science fiction and misinformation. Artists, however, find new metaphors in the absence paintings of veiled suns. Music composed from silence and static. Poems about the unseen. The comets inspire even in their disappearance. Speculation multiplies into cosmic theatre. What if Atlas and Swan meet behind the glare? What if their paths cross in ways we cannot track, exchanging matter or information? What if perihelion itself is the destination, the sun, the central hub where wanderers convene? None of this is proven. All of it is imagined, and yet it captures public imagination more powerfully than equations ever could. But absence is temporary. We know December will bring answers. Astronomers plan nights of re-emergence campaigns. Telescopes booked. Instruments tuned. Amateur observers, too, polish lenses. Ready for the first glimmer. The world prepares for the curtain to rise again. Will we find shattered ghosts or intact wanderers? Will the mysteries deepen or dissolve into ordinariness? We do not know. And perhaps that is the lesson. Science thrives not only on data but on waiting. Discovery is not a steady flow but a rhythm of silence and revelation. The comets teach us patience, humility before the cosmos, and the acceptance that we do not control the timing of knowledge. We are, like ancient watchers, dependent on the sky's permission. For now, the silence is our companion. The comets move unseen. The sun hides them, and humanity waits. And in that waiting, lies both tension and beauty. For sometimes, the most powerful chapter of a story is the one withheld. December arrives like the slow lifting of a curtain. For weeks, humanity has endured blindness. The comets hidden in the overwhelming brilliance of the Sunday telescopes have sat idle, their mirrors aching for photons that would not come. Amateur astronomers have stared at empty horizons, their excitement suspended in uncertainty. And then, in the chill of early December nights, faint smudges return to the sky. First one, then the other. The re-emergence begins. It is Swan R2 that reappears first, dimmer now, its once majestic tail shortened and ragged. Yet even in decline, it remains magnificent, a silver brushstroke across the dark canvas. Observers note the change immediately. Its brightness curve has flattened, its outgassing diminished. The giant that roared into autumn now limps into winter, battered but alive. Images from large observatories reveal dust streams twisted by solar wind, tails that break and reconnect. Evidence of struggles endured near perihelion. Swan has survived, but not without scars. 3. Eye divided by Atlas follows days later, smaller, subtler, harder to catch. It emerges as a green smear against the stars of Aquarius, its coma reduced but still unmistakably emerald. Astronomers breathe relief. Interstellar visitors are rare. Losing one in the glare would have been tragedy. The emerald glow lingers, subdued but stubborn, as if the wanderer refuses to vanish without offering more riddles. Its nickel lines persist, its iron absence still unexplained. Instruments confirm the composition remains as exotic as before. No simplification, no resolution, only deeper mystery. The return sparks frenzy. Data pours in from observatories worldwide. Spectrographs capture subtle shifts in emissions. Radio telescopes scan for outbursts. The James Webb turns its gaze once more, its infrared detectors passing thermal signatures from icy fragments. Mars orbiters send their caches of October observations, delayed but invaluable, painting a fuller picture of the flyby. Science sprints to make sense of the fragments before the comets fade beyond reach. The public, too, responds. Social media feeds flood with the first new images. Swan's ragged veil rising over rooftops. Atlas, a faint green pearl in telescopic frames. Communities that once mourned silence celebrate return. Hashtags trend, excitement rekindled. Children point upward again. Parents whispering, "That's it, that's the green comet we waited for." In living rooms and parks, the reappearance becomes a collective exhale, the relief of seeing lost friends come home. Yet the drama has shifted. The comets are weaker, less spectacular. For many, disappointment mixes with awe. Swan is no longer a showpiece. Atlas requires effort to see. Some call them spent, others dying. But in their fragility lies a new narrative. They are no longer heralds blazing across the heavens, they are survivors, limping yet enduring, carrying scars from encounters with the Sunday. And humanity, watching, feels kinship in that resilience. Scientists remind us that even fading light carries meaning. The tails, though diminished, preserve records of dust composition, revealing formation histories. Changes in brightness curves expose structural weakness, surface fractures, volatile layers. Every photon still counts. In laboratories, the data is precious, unique, irreplaceable. For interstellar visitors, especially, there is no second chance. The measurements taken now may stand for centuries, the definitive record until another wanderer crosses our path. Speculation does not end. If anything, it mutates. Some claim Swan and Atlas have completed their task and are withdrawing, their purpose fulfilled. Others frame the decline as evidence of transformation machines discarding shells, slipping into stealth. Fringe theories spread of fragments that are not fragments, but pods or probes, seeded deliberately. No evidence supports these ideas, yet they flourish in the cultural vacuum between data and meaning. The re-emergence, far from settling debates, fuels them anew. But alongside wild speculation blooms something more grounded: reflection. The comet's fading light becomes metaphor. We see in them our own arc-bright youth, peak brilliance, gradual decline, survival against odds. They remind us that all journeys end, that even stars exhaust their fuel. And yet, like Swan and Atlas, endurance itself is meaning. To survive the sun's fire and still be seen is a victory worth cherishing. As December deepens, the comets drift further, their light dimming each night. Soon they will be too faint for amateurs, then for mid-sized observatories, until only the largest telescopes can trace their paths. And then, inevitably, they will vanish again, this time not into glare, but into distance, fading into anonymity. The curtain will fall, not suddenly, but slowly, until memory is all that remains. But in that memory, October and December 2025 will live on. Two visitors, green and silver, arrived together, vanished together, and returned together. They reminded us that the cosmos is not static, but alive, not silent, but full of whispers. Their scars are now part of our story, written in spectra, in photographs, in whispered recollections of nights spent watching the sky. The re-emergence is not a conclusion, it is a reminder that discovery is fleeting, that awe is precious, and that even fading lights can illuminate more than we ever expected. When the two comets finally fade into the outer dark, the real work of science begins. Telescopes may no longer see their tails clearly, but hard drives are heavy with raw data. Terabytes of spectra, brightness curves, dust models, and orbital refinements. The task is monumental. Teams across continents pass the information, each lab specializing in a piece of the puzzle. Some focus on the volatile gases, others on dust grains, still others on orbital mechanics. What emerges is not a single narrative, but a mosaic fragments of truth pieced together by thousands of hands. For 3I divided by Atlas, the riddles remain sharp. Its dominance of carbon dioxide, its stubborn green glow, its nickel without iron, these anomalies refuse to dissolve under analysis. Theories multiply. Perhaps Atlas formed in a region of its home system where chemistry skewed toward rare ratios. Perhaps it was battered by cosmic radiation for millions of years, stripping iron from its surface. Perhaps it hides deeper reserves we could not see, its secrets buried beneath layers we never pierced. Each paper proposes explanations, but none settles the matter. The object remains an enigma, as interstellar wanderers often do. Swan R2, though more familiar, tells a parallel story of strangeness. Its rapid brightening, its enormous tail, its disconnections shaped by solar wind, all become case studies in comet dynamics. Its chemistry, rich in water and dust, matches Oort cloud expectations yet shows peculiarities in grain sizes and volatile distributions. In comparing Swan to Atlas, scientists glimpse something profound. Two comets, born in utterly different cradles, evolving side by side under the same Sunday. The comparison is a natural experiment the cosmos offered us freely, one we could never have designed. But science is never only numbers. The human dimension colors every report. Researchers describe the sleepless nights of October when telescopes raced to catch the last photons before the sun swallowed the sky. They recall the nervous weeks of silence in November, when nothing could be observed and speculation filled the void. They describe the relief of December, when faint smudges returned and data trickled back. These memories become part of the scientific record, informal but powerful reminders that discovery is lived, not just measured. Conferences in 2026 echo with the duet. Astronomers present side by side plots of Atlas's spectra and Swan's brightness curves. Panels debate whether the anomalies of Atlas warrant extraordinary interpretations or fit within natural variation. Graduate students present posters filled with colorful graphs, their excitement palpable as they speak of the October pair with reverence. The comets become case studies, their names etched into the annals of astronomy, alongside Halley, Hale-Bopp, and Oumuamua. Public memory lingers differently. For scientists, Atlas and Swan are datasets. For the wider world, they are experiences. Children remember green smudges and silver veils. Families recall autumn nights spent pointing upward. Social media archives overflow with photographs, paintings, and poems. The duet enters culture not as equations but as symbols, reminders that the sky can still surprise, still unite humanity in shared wonder. In universities, lectures on planetary science now include the October pair as a teaching moment. Professors describe how coincidence can feel like choreography, how anomalies spark imagination, how patience is part of discovery. Students who watched as teenagers now study astrophysics, inspired by those nights. Some will dedicate careers to interstellar visitors, carrying forward the questions Atlas left behind. Yet perhaps the most enduring legacy is philosophical. The duet forced humanity to ask not only what, but why. Why together? Why now? Why visible to us? Science answers with probability and physics. But for many, the deeper answer is that meaning is ours to create. The comets themselves may not care, but we do, and in our care lies significance. As Atlas vanishes into interstellar night and Swan retreats to the frozen edges of the solar system, they leave no messages, no deliberate signals, and yet, in their coincidence, they gave us one anyway. They reminded us that the universe is vast, unpredictable, alive with mystery. They taught us humility and awe, and they showed that even fleeting lights can alter how we see ourselves. In the end, the data will be archived, the papers written, the debates simmered, but in memory, October 2025 will forever be the season when two wanderers crossed paths by our sun and, for a brief, brilliant moment, let humanity watch. The duet of three, I, divided by Atlas and Swan R2, does not end with their fading light. It begins again in the realm of interpretation. The scientific papers, sober and precise, capture what is measurable: emission lines, dust-to-gas ratios, orbital refinements. Yet beyond those charts lies a more elusive legacy, the way the comets reshaped how humanity thinks about coincidence, meaning, and destiny. Philosophers seize on the moment. For centuries, thinkers have debated whether the universe is governed by blind chance or hidden purpose. The arrival of two strangers at once, so different yet so synchronized, feels like a case study in that ancient question. Was it nothing more than probability stretched to its improbable limit? Or was it a sign of patterns we do not yet perceive, threads woven into the fabric of reality that science has not caught up with? Essays spill from journals and blogs alike, weaving cosmic speculation into arguments about fate and free will. Theologians, too, respond. In some traditions, the comets are embraced as signs of divine narrative reminders that creation is not silent, but speaks in light. In others, they become metaphors for pilgrimage, wanderers seeking a source of energy, just as humans seek meaning. A few even suggest that their pairing is a mirror of humanity itself. We, too, are dual in nature, scientific and spiritual, rational and imaginative, bound by physics yet yearning for purpose. Poets and artists translate photons into metaphor. In galleries, canvases depict an emerald spear crossing a silver veil. In music, composers score pieces where two themes begin apart and then converge, harmonizing before fading into silence. Writers craft stories where comets are messengers, lovers, or adversaries, locked in eternal dance. In every medium, the October duet becomes symbol of unity, of duality, of fleeting brilliance. Culturally, The comets become reference points. Children born in 2025 will grow up hearing their parents say, "I saw the green comet," and the Great Veil. Just as Halley marked earlier generations, Atlas and Swan mark this one. Festivals form in some cities, commemorating their arrival with lanterns painted green and white. Schools adopt the duet as a teaching tool, blending astronomy with literature and philosophy, reminding students that science is not only about data, but about wonder. In political and social spheres, the duet leaves echoes too. International cooperation during those weeks, data sharing, joint observation campaigns, coordinated funding sets a precedent. Space is suddenly understood not just as competition but as shared heritage. Governments that once guarded data fiercely learn the power of open collaboration, at least briefly. The comets, without intent, nudged humanity toward cooperation, yet the philosophical resonance cuts deeper. They force us to reckon with fragility. If two icy wanderers, born in different cradles of the galaxy, can meet here and now, then so can destruction. Coincidence cuts both ways. It can deliver beauty or catastrophe. Humanity is reminded that cosmic events are indifferent to our existence, yet capable of reshaping it. The comets inspire awe, but also humility. For many, the enduring lesson is about perspective. We are small, yet not irrelevant. We are fleeting, yet capable of noticing, recording, and interpreting. The universe may or may not hold intention, but we hold the power to create meaning from its silence. In that sense, the duet was never just about comets. It was about us, about what we choose to see, about how we choose to tell the story. Perhaps the ultimate irony is this: whether Swan and Atlas were mere coincidences or something more, their impact on humanity is the same. They united science and art, reason and myth, skepticism and imagination. They reminded us that wonder is not naive but necessary, that mystery is not ignorance but invitation. As the archives close and the night skies grow empty again, philosophers will continue to argue, poets will continue to sing, and children will continue to ask, why did they come together? The only honest answer may be, we do not know. And perhaps that is the point. For sometimes the greatest gift the universe can offer is not certainty, but wonder that refuses to be resolved. What remains when the light fades? Not the comets themselves, those wanderers recede into darkness. One to the frozen outskirts of the solar system, the other back into the uncharted sea of interstellar night. What remains is memory. October 2025 is gone, yet it lingers in human minds, in photographs, in poems, in archives of spectral data stored on servers across the globe. The duet of 3I divided by Atlas and Swan R2 becomes part of our collective story, layered onto the long tradition of skywatching that stretches back to cave paintings and stone observatories. Memory works differently for different people. For scientists, the legacy is a library of measurements: nickel without iron, carbon dioxide dominance, green emissions, brightness curves, orbital solutions. These datasets will live in journals, cited by future graduate students who were children during the spectacle. They will analyze the anomalies with new instruments decades from now, perhaps finally unraveling mysteries we could not. In the patient world of science, memory is a seed planted for harvest in future generations. For ordinary people, memory is visceral. A father remembers taking his daughter to a hilltop, showing her swan's veil stretching across the horizon. A teenager recalls sneaking out to glimpse Atlas through a telescope, the faint emerald smudge that seemed to pulse with otherworldly life. Families recall evenings spent together under skies suddenly alive. These memories are not data, they are emotion, woven into the fabric of personal histories. To those who lived it, October 2025 will always be the season of two comets. Cultural memory grows too. The duet seeps into art, music, literature, Novels feature twin wanderers as metaphors for love and loss. Artists paint emerald and silver arcs across canvases. Musicians compose symphonies where two themes converge, echoing the comet's approach. Even fashion borrows from the moment. Designers incorporate comet tails into patterns, emerald green into seasonal palettes. In countless subtle ways, the duet inscribes itself onto culture, not as astronomy but as inspiration. Memory also shapes identity. Nations boast of their contributions, images captured by their telescopes, data returned by their spacecraft, papers published by their scientists. Space agencies highlight the October pair as proof of their relevance. Educational institutions brand themselves around the event, using comet imagery in logos, naming scholarships after Atlas and Swan. Memory becomes legacy, and legacy becomes narrative. We were here, we saw, we recorded. But memory is fragile too. As years pass, the vividness dims. The comets fade into textbooks, their names reduced to acronyms and catalogue numbers. Children who once gazed upward grow older, their memories blurring into anecdotes told to disbelieving grandchildren. Without preservation, awe evaporates. That is why archives matter, not just scientific databases, but cultural ones. Photographs, diaries, social posts, even whispered stories are part of the record. They ensure that wonder does not vanish completely. Philosophically, memory is also interpretation. Was October 2025 coincidence or choreography? Science may lean toward probability, but culture leans toward meaning. In memory, the debate persists. Some will recall it as proof that the universe stages patterns. Others will remember it as a lesson in humility that even when coincidences happen, they remind us of our tiny place in a vast cosmos. The truth may never be agreed upon, but the memory of the questions is itself enduring. For humanity, memory is not passive. It is generative. The memory of Halley inspired research, art, even superstitions that lasted centuries. The memory of Oumuamua spurred debates about interstellar probes. The memory of the October pair will do the same. Future missions will be proposed in their name: faster interceptors, more vigilant surveys, spacecraft designed to chase the next interstellar visitor before it vanishes. Memory, in this sense, becomes momentum. And perhaps that is the greatest legacy of three. I divided by Atlas and Swan R2. They will not remain bright forever, but the memory of them, of green fire and silver veil, of coincidence and speculation, will propel humanity to look harder, to prepare better, to dream bolder. For in the end, comets are fleeting, but memory endures, and in memory lies both meaning and possibility. Legacies are not always chosen, they are shaped by what comes after. For three, I divided by Atlas and Swan R2. The legacies they leave are neither tales of dust nor trails of gas, but the human responses they ignited. Their duet becomes a benchmark, a hinge in the story of how humanity relates to the cosmos. The October pair, as they are now called, remind us that discovery is not simply about what is observed, but about what is remembered, retold, and reimagined. In the scientific record, the legacy is precision. Entire disciplines sharpen their tools because of October 2025. Surveys expand, software improves, instruments gain new calibration. Astronomers vow never again to be so blind at perihelion, pushing for sunward-facing spacecraft, coronagraphs optimized for faint comae, missions able to pivot quickly to intercept new wanderers. The duet becomes a case study in both wonder and limitation, how much we learned and how much we missed. The gaps in data become motivators, fueling funding proposals and research agendas for decades. In the cultural record, the legacy is awe. Artists still paint the green spear and the silver veil. Poets still write of twin wanderers as metaphors for love, fate, or destiny. The comets slip into myths the way Halley once did. Festivals commemorate them with lanterns painted green and white, music composed in two voices converging into harmony. The imagery of October 2025 becomes shorthand for the unexpected beauty of coincidence, for fleeting brilliance, for the reminder that the sky is alive. In the personal record, the legacy is intimacy. People remember where they stood when they saw Swan's tail sweeping across twilight, or Atlas glowing faintly green against the stars. Families pass down stories. I was there. I saw them with my own eyes. Such memories outlast data sets. They become anchors in personal histories, moments when the universe itself seemed to touch everyday life. But the greatest legacy is philosophical. The duet forced us to confront questions we cannot answer. Coincidence or choreography, natural or intentional, silence or signal. Those questions remain unresolved, yet they matter. They remind us that science does not erase mystery but reframes it. They teach us that awe is not weakness but strength, the fuel of inquiry, the spark of imagination. And they reveal that even if the universe is indifferent, we are not. We choose to give meaning, and in that choice lies humanity's deepest power. Some say the October pair will be forgotten, that memory fades as new wonders arrive. Yet every generation preserves a few moments that endure. Apollo's footprints, Voyager's golden record, Halley's long arc, Atlas and Swan, by arriving together, joined that canon. They will live on in textbooks, in art, in whispered recollections, in the drive to build faster spacecraft for the next time the sky delivers an interstellar gift. Perhaps their legacy is this: they showed us the value of attention. To look up, to notice, to wonder, to see coincidence, not as trivial, but as invitation. To recognize that sometimes the universe offers us beauty without explanation, and that it is enough to witness, even if we cannot yet understand. And so, as they fade into silence, the legacy of 3I divided by Atlas and Swan R2 is not only theirs but ours. They leave us not with certainty, but with a gift, the reminder that the cosmos is alive with questions, and that the act of asking them is what makes us human. Legacies expand with time, like ripples on water. A year after the duet of 3I divided by Atlas and Swan R2, their influence still spreads outward, not in their fading dust, but in human projects inspired by their memory. Space agencies propose new missions, rapid, response interceptors designed to chase interstellar visitors within weeks of discovery, solar probes equipped with coronagraphs to pierce the sun's glare, dedicated spacecraft to patrol the solar system for wanderers. October 2025 becomes a rallying cry, proof that the cosmos offers gifts we are not yet ready to grasp. At universities, students inspired by those nights now pursue astrophysics, planetary science, and aerospace engineering. Professors speak of the October pair as a turning point, a reminder that science is not static but alive, demanding readiness for the unexpected. New textbooks devote chapters to Atlas's nickel lines, to Swan's luminous tail, to the power of coincidence as a natural experiment. For young minds, these comets are not abstractions, they are reasons to dream bigger. The duet also seeds collaborations across borders. Nations that once guarded data now share it more openly, having seen the futility of secrecy when the sky itself belongs to everyone. Amateur astronomers gain new respect. Swan R2's discovery by an attentive observer reminds the world that science is democratic, that wonder does not require a badge. Partnerships between professionals and amateurs flourish, turning backyards into outposts of discovery. But the most enduring expansion is cultural. The green of Atlas and the silver of Swan enter symbolism. In novels, they are lovers who meet briefly before parting forever. In films, they are cosmic omens, heralds of change. In art, they appear as twin arcs, one sharp and emerald, one vast and veiled, painted on murals, album covers, even children's storybooks. The duet becomes shorthand for the fleeting nature of beauty, for the power of moments that will never repeat. Philosophically, their expansion forces a deeper humility. We now know Wanderers from other stars can and will pass through our solar system. We cannot predict when. We cannot command their arrival. All we can do is notice, record, imagine. Atlas and Swan remind us that the universe's timetable is not ours, but that meaning is always ours to create. Their legacy expands not by certainty, but by awe. Time will blur their details, but not their echo. A decade from now, most people may not remember the chemical puzzles of Atlas or the rapid brightening of Swan. What they will remember is that autumn when two comets appeared at once, one green, one silver, and the world looked up together. And perhaps that is the ultimate measure of legacy, not how long data persists, but how deeply wonder imprints itself on human hearts. Future missions may chase new interstellar visitors, perhaps even launch probes fast enough to intercept them. When they do, they will cite October 2025 as the spark. The archives of spectra and images will still be studied, still debated, perhaps even reinterpreted in the light of new theories. If one day we discover evidence of technology cloaked in cometary disguise, scholars will look back and say, the signs were there. If not, then Atlas and Swan will remain natural marvels, still no less meaningful. But beyond science and speculation lies something subtler, memory as ritual. Families who once watched together will retell the story. Children will recall, my parents took me outside to see the green comet. Artists will still paint them, poets still write of them, musicians still echo their duet in sound. October 2025 will join the small pantheon of nights when humanity felt united by the sky like eclipses, like meteor showers, like the first steps on the moon. In the end, the duet's enduring power is its refusal to be resolved. Were they coincidence or choreography, wanderers or messengers? The answer will never be final. And perhaps that is why they matter. They remind us that not everything can be concluded, that mystery is not failure, but invitation. Their final gift is a paradox. Two fleeting visitors who, by departing, left something that endures. Thus their story does not close, it lingers. In datasets, in memories, in art, in philosophy, in the restless questions we keep asking. 3I divided by Atlas and Swan R2 may never meet again, but their duet will echo for generations. They showed us the cosmos not as silence, but as conversation, however cryptic. And in doing so, they reminded us of what it means to be human, to look up, to wonder, to never stop searching for meaning in the stars.